everyone. Welcome to the TVE Happy Math Hour, our weekly interactive math reviews for Math 1314 and Math 1324, presented by Ms. Yvette Shuka, Mr. Ruben Carizales, and Mr. Albert Isasi. Our session will be starting soon. The session is going to be recorded so that you can come back to it later if you need to, and so that others who have missed out today's event will be able to come and watch it later. So thank you for being here. At this time, please mute your mics for the best sound experience. Otherwise, the feedback could interfere with information we will be sharing today. We will be sending the Math 1324 room link in the chat so that you can connect to that session if you're here for Math 1324. A very, very important announcement. We are not doing sign-in sheets this semester. Instead, we are logging students in through MyScio. So during the presentations, Ms. Patricia will be reaching out to each and every one of you for your EPCC ID number, your instructor's name, to make sure you receive credit for being here today. Please respond to her so she can sign you in. So without further ado, I will pass it on to our presenters so that we may begin. Thank you.
Hello, Mr. Ortiz, if you are in 1324, then you can click on the link and go to that class. If you're in 1314, then you can stay in this room. Okay, so today we're gonna be starting, we're gonna be talking about synthetic division and complex numbers for 1314. So we'll get started with that here in a second. All right, so let's go ahead and start. So in the previous section, we have been talking about zeros. And so here's an example of a zero that is touching at x equals 2. And so since we know that x equals 2 is a zero, if I was to take the 2 to the other side, then we create what we call a factor. So x minus 2 is going to be called a factor. And we're going to be using these terms later on in the chapter. Okay, so we'll go on. In this section, what we want to do is we're going to look at two ways of dividing polynomials, and these two ways will also help us to find these zeros that we will need to find in order to graph a polynomial. So the first one is called long division. And for long division, these are the steps that we're going to be using. So the first thing you're going to want to do is arrange the terms of the dividend and the divisor, and I'll explain what these terms are here in a second. And we're going to write them from descending powers. So we're going to write them in order. Then we're going to divide the first term by the first term of the divisor. And then we're going to go ahead and multiply and subtract. So essentially, what we're going to be doing is the following. So let me just get my pencil out. Okay, so whenever you divide a number, let's say we have 3 divided by, let's say we have 172 divided by 3, then the outside number that we're dividing by is your divisor, and the inside number is your dividend. And so how do we do this? So we ask ourselves, how many times does 3 go into 17, for example? So we say 5, right? And then what do we do with the 5 and the 3? We multiply 5 times 3, so we get 15. And then our next step is we subtract. And so when we subtract here, we get a 2. And then our next number here, we bring it down. And then we follow the same process, right? So how many times does 3 go into 22? So that would be 7. And then we continue doing the process. So whenever we're working with polynomials, we're going to follow the same idea. Okay, so let's go on to see an example. So let me just keep going here. So here's two polynomials. So we have 20x cubed minus 35x squared plus 23x minus 6 divided by 4x minus 3. So we want to use long division to divide. So the first thing we're going to do is we're going to write our divisor on the outside. And then we want to make sure that our terms here are in descending orders from the powers. So here we have a 3, here we have a 2, then we have a 1, and then we have our constant. If you're missing any of these or any of these exponents, so example, if we didn't have an x squared term, then you want to make sure that we include a 0. Okay, so our first step is going to be to look at the first term of the divisor and the first term of the dividend. And basically, if you divide those, what we're essentially saying is how many times does 4x go into 20x cubed? So if we divide them, we see that we get 5x squared. So we're going to write that on the top. And then we're going to multiply. So 5x squared times 4x. Okay, so 5x squared times 4x is 20x cubed. And 5x squared times 3 is negative 15x squared. So just like I did in the first slide, we need to subtract are the information we get after we multiply. But notice I'm going to put a parenthesis here because I'm subtracting the entire polynomial here. So in order for me to subtract, I'm going to go ahead and distribute my negative into the parentheses. So I end up with negative 20x cubed plus 15x squared. So now I can go ahead and simplify here. So 20x cubed minus 20x cubed is 0. Negative 35x squared plus 15x squared is negative 20x squared. We're going to bring down the 23x, and then we're going to repeat the same process. So we're going to look at 23x. And so let me just rewrite it here, right? So we're going to look at the 23x and the 4. How many times does 4x go into 23? And it goes in 5x times, right? So negative 5x times 4x is going to be a negative 20x squared. Negative 5x times negative 3 is positive 15x. Don't forget, we're subtracting the entire thing. And so we're going to go ahead and simplify that. So negative is a positive 20x squared. Negative and positive 15x is a negative 15x. If I add these together, I get 0. And then 23x minus 15x is 8x. Bring down the 6. So then I multiply 2, or we can continue, right? So if we have our 8x, how many times does 4x go into 8x? That's going to be a 2. So 2 times 4x is a negative 8x, a positive 8x, and then 2 times negative 3 is a negative 6. But what happens is, because we have to subtract, then what I'm doing is changing the signs of my two terms. So if we change our signs, we get 0 here, and then we get 0. So later on in this chapter, if you end up with a 0 remainder, then that's going to be a really good thing. And so these are the terms that we're going to have here. We have 0 is going to be our remainder. This number on the top here, this result up here is called our quotient. And then the number we're dividing by is called our divisor. So when you enter your answers on WebAssign, they're going to want you to enter it as the quotient plus the remainder divided by the divisor. So this polynomial here divided by our divisor is equal to 5x squared minus 5x plus 2 plus 0, because we had a 0 remainder, divided by 4x minus 3. Now long division is one way to do it, but there is what we think is a simpler method, and so that is called synthetic division. And for synthetic division, it is like a shortcut for long division. And our divisor, the thing that we're dividing by, is going to be in this form, x minus c. So if you have a polynomial and you're dividing by a number, x minus k, or I could say x minus c, then this is the process we're going to take. We're going to make sure that our terms are in descending order. So again, your exponents here should be in descending order, 3, 2, 1, and so on. We're going to identify each coefficient and use a 0 for any terms that are missing. So my coefficient for x cubed is a. my coefficient for x squared is b, and then my coefficient for x is c, and then our constant is d. If we didn't have an x, for example, then we would place a 0 in that place holder. So then k is what we're dividing by here. So we have x minus k. So k is going to be written on the left side here. And so we're going to draw this this kind of like an L that's laying on the side here. So you're going to put your divisor here, your coefficients here. And then the next step we're going to do is we're going to bring the a down. And then after we bring the a down, we're going to multiply it times k. So we get k times a. And then we're going to add it to the b. So we have b plus k times a. And then we're going to repeat the same process. Okay. So with numbers, it'll be a little bit easier to follow. So let's try an example. Now, well, before I move on, the last number you get here, that's called your remainder. And then whatever's before your remainder is what's going to make up your quotient. Okay. So let's look at an example. So use synthetic division to divide x squared plus 5x plus 6 by x minus 1. So what is k? What is our k in this situation? Okay, so our k is going to be that 1. So next we're going to list the coefficients. So the coefficient of x squared is 1. The coefficient of x is 5. And then we have our constant. So we're going to list our numbers here. Okay, so then the next step is to bring the first number down. And then we're going to multiply it times the k. So 1 times 1 is 1. And then we're going to add. So 5 plus 1 is 6. And then we're going to follow the same process. 1 times 6 is 6. And 6 plus 6 is going to be 12. Okay. So now that we're done, we need to write what our remainder is and what our quotient is. So our remainder is going to be the 12. And the numbers to the left of that is going to be what makes up our quotient. Okay, so our quotient, let me go ahead and go to our quotient. So our quotient here is going to be 1 degree less than our dividend. So if you notice here, our dividend the degree was a 2. So our quotient is going to start with 1 degree less. So this 1 here would be x. And notice that the power of x here is just 1. And then we have 6 is our constant. Then we're going to have our remainder 12 divided by our divisor, which was x minus 1. Okay. So if you start with x squared is your dividend, when you start your quotient, it should be 1 power less. That's why we started with a power of 1. Okay, so I have about 3 or 4 of these that we're going to practice, and each one has something a little bit different that we can look at. So if we look at this one, if you go ahead and identify what C is, what is C going to be in this situation? Any guesses? 32, okay. Any other guesses? And so C is our constant, or our constant is negative 32. But the one that we're looking for is, and I should have probably, so that was my mistake. I should have asked for K. So our K is going to be 8. Okay. So we're going to place 8 right here. And then we're going to write our coefficients. So here are going to be my coefficients. 4, 36, 36, and negative 32. Notice that you do have to make sure that they're listed in descending order, which they are. So we're good to go. So our next step is to bring down the 4. And now we're going to do multiplication of 8 times 4. So we're going to multiply 8 times 4, and that's going to give us a 32. So now with 36 and 32, we're going to add those. So that gives us a 68. Okay. So what is my next step here? In order for me to get the next number, what do I need to do? Any suggestions? multiply. Okay, so we're going to multiply 8 times 68, and that's going to give us 544. And now we're going to add it to the 36, and we get 580. Then we're going to continue the process, right? So 8 times 580 is 4,640. If we subtract 32, we end up with 4,608. So of all these four numbers, which one is my remainder? The last number, right? So 4,608 is our remainder. And then to write our quotient, since we had a degree of 3, this first coefficient would be a 4x and 1 degree less. So instead of 3, we're going to go 1 degree less. So we'll have 4x squared plus 68x plus 580 plus your remainder, 4,608, divided by x minus 8. Okay, so let's try another one. Let's try this one. So first, let's identify what k is. Okay, so k, notice that in the previous ones we had x minus a number, but now we have a plus. Okay, so we need to figure out this x plus 7. We can easily write it as x minus negative 7. So our k is going to be negative 7. So whatever you're showing here, it's going to be the opposite number that we use. So since you have a plus 7, we're going to be using a minus 7. So that would go here. Any questions on that part? Okay, so take about 10 seconds and decide what numbers are going to go in here. Okay. So hopefully you thought to yourself what number should go in there. And so if you thought about 3, and if you put a negative 6 here, then that's incorrect, right? Because we have to make sure that our polynomial is in descending order. So I had to rewrite it as 3x cubed plus 21x squared minus 6x minus 42. So my coefficients are 3, 21, negative 6, and negative 42. So now we can start the process. So we're going to bring down the 3, multiply times negative 7. So we get negative 21. And 21 plus negative 21 is going to be 0. And we start a process again. 0 times negative 7 is 0. Plus a negative 6 is negative 6 times negative 7. And that's going to be a 42. And if we add negative 42, then we end up with 0. And so, Mr. Carizales, there you go. If you have a 0 there, it's going to be super exciting, just like the happy face Mr. Carizales put up there. And why is that going to be the case? And we'll talk about that shortly, but just remember this is going to be good news for us if it has a 0. So my quotient is going to be 3, and then we're going to have our x, but instead of a cube, we're going to start with squared. So we end up with 3x squared plus 0x minus 6 plus 0 is our remainder, divided by our divisor x plus 7. And you can rewrite it. You don't have to leave it as 0x. So this would be our quotient. Okay. Let's try one more. So here our k is going to be 5 or negative 5. What do you guys think? 5. Okay. So that is correct. We're going to use 5. Okay. So here's going to be our 5. And then for our coefficients, we have x cubed, negative 3x squared, but I'm missing an x. So it's important for me to write a 0 as our placeholder. So we're going to have 0 times x. So my coefficients are going to be 1, -3, 0, and then 6. So we start a process, bring the 1 down, times 5, and then add the -3. So that gives me a 2. 5 times 2 is 10, plus 0 is going to be 10. And then 5 times 10 is 50, plus 6, 56. And so our quotient is going to be, oops, I went too fast, x squared plus 2x plus 10 plus 56 divided by x minus 5. Okay, so let me go back just so I don't leave you hanging here to tell you why Mr. Carizales was super excited to get a 0 here. Okay, so basically later on in the next few sections, we're going to have to graph these polynomials. And so if you get a 0 in the remainder, then that tells you that this guy, the one we're dividing by, is a 0. So at -7, you're going to have a 0 here. And so your graph might do something like, this is not the real graph. I'm just assuming that it's going to be. Okay, so you know that you're going to have an x-intercept at this point here. Now, whenever we have like these problems where we ended up with a number other than 0, then at x equals 5, your graph is not going to cross through that point. Okay, and we'll get into that. I don't know if we're going to have it in this section, but for sure next week is going to be about finding those zeros. And so next week will be probably, in my opinion, the section that sometimes students struggle with, but in my opinion, it's my favorite section. So we'll be finding all those zeros and graphing. Okay, so let's look at another little thing here, the remainder theorem. So remember in the previous examples, this is the remainder. And so this is just a way to find the remainder. So it says if a polynomial f of x is divided by x minus k, then the remainder can be found by f of k. So basically putting this k into all your x's and solving for y. So we'll look at an example. If you use synthetic division, then this was the process, right? We have 2, 0, -7, and 2. We're getting that from here. F of 1, that tells us that x is equal to 1. And so if I write it in this form, we have x minus 1. I'm dividing by 1 here. And if I do all my work, then I can see that my remainder is -3. So that's one way to do it. However, if you use the remainder theorem, okay, what it says is that you can take the value for x, which is 1, plug it into your x's here, evaluate the function. So 1 cubed is 1 times 2, and then -7 times 1 is -7 plus 2. And this number that you get at the end, that's going to be your remainder. So notice we ended up with the same remainder. Okay. So for f of -2, if I did the synthetic work, then we end up with 0. Since I get a 0 here, that means that x equals -2 is a 0. And then if I did it the remainder way, with the remainder theorem, you still have the same remainder. Okay. So if you see problems that say, find the remainder, then you have choices, right? You can do it this way, or you can do the remainder theorem. Questions on that? Okay. So how does synthetic division help us solve equations? So you're going to be asked to find the zeros. And then here they tell you that x equals -2 is a 0. If they tell you that x equals -2 is a 0, and then they give you your polynomial, we can use synthetic division. So I would set up my 2, my -7, and my 2. I'm missing an x squared. That's why I have a 0 here. And now that I know that x equals -2 is a 0, I'm going to be dividing by -2 here. Okay. So if I do my work, bring down the 2 times negative 2 is negative 4 plus 0 is negative 4 times negative 2 is positive 8 plus negative 7 is 1 times negative 2 is negative 2, and I end up with a 0. If you ended up with a different number, then you know that you did something wrong, because since they tell me that it's a 0, my remainder better be a 0. Okay? So that gives me the solution that x is equal to negative 2. That's one solution. But I need to find all the other solutions. And so this is why synthetic division is important, because we're going to use the quotient here. In this example, the quotient is 2x squared minus 4x plus 1. And notice that my quotient is now quadratic. Okay. And so in 2.1, you learn that you can factor some of these quadratics, or you can use a quadratic equation. Or in some instances, you could use a square root property. So you could use any method that will work for this polynomial here. And so we're going to go ahead and factor. Okay, so we get 2x minus 1 times 2x minus 1 is going to give me this polynomial. And if I solve for x, I get add the 1 on both sides, divide by 2, I get x equals a half. And if I divide by or subtract 1, add 1, I get a half as well. So now I have 3 zeros here. X is a half, x is a half, and x is 0. And notice that my degree is 3, so I should end up with 3 zeros. Okay. In this case, my 0 is repeated. It's the same 0. Does anybody remember what happens to your graph at that point? Does it touch or does it cross? And let me see, I don't think I have a graph of this, but okay, let's check. Okay, so Ms. Patricia said that it touches. So what we just found is this here. You're going to have a 0 here, and then you're going to have, oops, another half, another 0 around here. And so all we know right now is that at this point right here, at 0, your graph is going to cross, but at a half, it's going to touch. So it's either going to touch this way or it might touch this way. Okay, so how do you know which way it's going to touch? Well, that's going to play into the end behavior. So remember the end behavior. Since this is odd and this is even, your graph is going to be looking something like that. Okay. So anyway, so that's how we're going to use synthetic division to help us find the zeros. So in the next section, 2.5, you'll be able to use what you learned last week, which was the end behavior and the multiplicity of zeros. And now with this synthetic division, you'll be able to use all of that information to make a graph. Okay. But in the meantime, we're going to be switching a little bit to something called complex numbers. And the complex numbers are numbers. It's a a new number system that was created to help us solve for equations that look like this. Because if you're trying to solve for x squared for x here, we would subtract the 1, and then we would take the square root like we did here. But once we have that negative in here, then we know that there's no real solution. Okay. So in order for the mathematicians to continue their work, they said, let's create this whole new number system so that we can proceed. Okay. And so it's the complex numbers, and actually you might know it as the imaginary numbers. Okay. So whenever you have this type of solution here, if you have no real solution, that means that your graph is not going to cross these x-axis. So your graph is going to be either up here or it's going to be down here somewhere, but it's not going to cross the x-axis. In this example, this would be well, neither one is the answer, right? So our graph would be at x squared plus 1, so it would be down here somewhere. But the point is that it's not going to cross the x-axis. Okay, so instead we have an imaginary solution an imaginary number, which we call I. And so I is equal to the square root of -1. And if we square both sides, then I squared is equal to -1. So you want to remember this part right here is that I squared is equal to -1. And then you also want to remember that if you have a negative in the square root, then we're going to use this imaginary solution. The standard form on the computer WebAssign, they're going to be asking you to write your number in standard form. So this is a standard form. So it's A plus BI, where A is the real part and then BI is your imaginary part. So in order to develop a new number system, we can't just develop a new number system and then just say like, oh, I have a new number system. It had to go through the same operations as our regular number system. And so what we're going to be doing in the next slide here is we want to be able to add and subtract these complex numbers. Okay. So there is a formal way of doing this, and then there's an informal way of doing this. I'm going to show you both. So the definition here, if you're wanting to add, is that you add the real parts first, A plus C. That's your real part. And then you add the imaginary part, BI plus DI. And that's going to be your imaginary part. And for subtraction, we would do the same, A minus C, and then B minus D. Okay. So we're going to practice some of these. So we'll do the first one. Excuse me. So if you wanted to use a definition, I went ahead and wrote it here for us to see. And then our two complex numbers are 3 plus I and 6 plus 5I. So we would add 3 plus 6, and then we're going to add the 1, because there's a 1 in front of I, plus 5. And so we get 3 plus 6 is 9, and 1 plus 5 is 6. So this was going to be our answer. Okay. But the method that I use is just combine like terms. So what I mean by that is we have our 3 plus I plus 6 plus 5I. So I just take them out of the parentheses and I combine like terms. So 3 and 6 are like terms. So that's 9. Then I have 1 I and then I have 5 I's. So together that will give me 6 I's. Okay. So you can use whichever method you feel more comfortable with. Let's try another one. Now we're subtracting. So if you use the formula, you would have 3 minus 2, and then the -1 minus a -1. And so 3 minus 2 is 1, -1 minus a -1 is 0. So we end up with 1. If you're using just combining terms, you would distribute the negative into the parentheses. So you end up with a -2. And then a negative times a negative is a positive I. So 3 minus 2 is 1, and -1 or negative I plus I is going to be 1. So in standard form, though, you would, and I don't remember if maybe Mr. Carizales remembers, they might still want you to write it as 1 plus 0I to include that imaginary part, or if 1 is okay by itself. I don't remember. I forgot. So if you just put the 1, do you remember, Mr. Carizales?
It's the website is tricky. Sometimes they will accept it, and sometimes they won't. But if you get in a habit of always doing it in standard form, the real plus imaginary, you'll never go wrong. So that's what I tell my students. Always just put it in standard form because you never know.
That's true. So 1 plus 0I would be your standard form. If for some reason you happen to get it wrong, then just try the 1, right? And if you still get it wrong, then ask your instructor to check to see what they want, right? At least if you're my student and you ask me, I'll check to see what's going on. All right, so we added and we multiplied, okay? So now we have a different situation here, right? So we have -3 plus the square root of -8 plus 5 minus the square root of -56. So what you want to do first is deal with these negatives, right, inside of the square roots. So we have a -3 plus the square root of -8 plus 5 minus square root of -56. So for the -8, I'm going to go ahead and write it as -1 times 8. So that's the same number, right? I'm just rewriting it. And -56, I'm going to write it as -1 times 56. Now, the reason I want to do that is because remember that I squared is equal to -1. So anywhere I see a -1 here, I can replace it with I squared. And -1 is I squared. So I'm going to go ahead and add -3 plus 5 because those are common terms. And I get a 2. And then now I can deal with this I squared, the square root of I squared. Okay. So let me just write it on the side here really quick. So this right here is the same as the square root of -1 times the square root of 8. So this -1, we wrote it as I squared. So the square root of I squared, remember the square root and the power of 2 become a 1, or we say that they canceled. And that's why we're getting just an I. Okay, so let's go ahead and continue here. So I squared is just I, and then I have square root of 8. I squared is going to come out as I, and then I have 56. Well, in order for me to add or subtract these square roots, they have to have the same number inside, the same radicand. So we want to simplify those square roots. So the square root of 8, I can simplify it as 4 times 2. And now I can say that the square root of 4, and let me write on this side. Here I can have 4 times 4, 14, right? So let's look at this one closer. The square root of 4 comes out as a 2. And I already have my I there. And then the 2 is not a perfect square, so it has to stay inside. And then for this one, we have a 4. It's going to come out as a 2. And then the 14 is not a perfect square, so it's going to have to stay here. Okay, now the square root of 2 and the square root of 14, I cannot add those because they don't have the same number inside. They don't have the same radicand. However, if you notice, they both have an I here and they both have a 2, so I could factor out a 2i, but in this case, I factored out an I first. So and the reason I want to do that is so that I can write it in standard form. Okay, so that's why I actually kept the 2 there. So now we have 2 plus I, and then this whole number here. Okay. Now what about multiplication? So let's see about multiplication. We just multiply the same way we would if this was an x. So we have 1 times 8 is 8. 1 times -7i is -7i. I times 8 is 8i. And I times -7i is -7i squared. So we need to combine like terms. And I squared, what is that equal to? I squared. So if you recall from before, I squared is -1. Okay. So anywhere I see I squared, I want to replace it with a -1. So I'm going to have 8. -7i plus 8i is just 1i. So here's my 1i minus 7, and then I squared is -1. So we simplify, we get 8 plus I plus 7. 8 plus 7 is 15, and then we have our I. Okay, let's try this one. So here we're going to multiply 17i times 1 is 17i. 17i times -7i is -119i squared. We want to simplify, so there's that I squared again. We can replace it with a -1, and then -119 times -1 is positive. And so we have 17i plus 119. So our standard form is 119 plus 17i. Okay. Now division, right? So we're dividing these two together. So it says write the quotient in standard form. So the first thing we want to do is we're going to be getting something called the conjugate, okay? And the conjugate is coming, we're going to get the conjugate of the denominator. So the conjugate is just going to be the same real part and the same imaginary part, but instead of a minus, we're going to write it as addition, okay? So for example, if I had 2 minus 4i, then the conjugate is 2 plus 4i. If we had 3 plus I, our conjugate is 3 minus I. Okay, so let's continue here. So the conjugate of 5 minus 6i is going to be 5 plus 6i. Then you're going to multiply the numerator and the denominator by that conjugate. Okay, so here's my, and I can do that because 5 plus 6i divided by 5 plus 6i is just 1. So it's not changing the problem. We're just going to change the way it looks. So we're going to multiply these out. So we have 3 times this whole thing here, and this one times this one, as I wrote it there. So 3 times 5 is 15. 3 times 6 is 18i. And then 5 times 5, 25. 5 times 6, 30i. Negative 6i times 5, negative 30i. Negative 6i times 6i, 36i squared. So notice here that 30i minus 30i is actually a 0, okay? And when you multiply conjugates here, that's always going to happen. You're going to end up with a 0 here, okay? So there is another way to multiply these a little bit quicker, knowing that this is always going to produce a 0. And that is to square the 5, you get a 25. Square the 6, you get a 36. Okay, so if I simplify, this becomes a 0, and we have 25 minus 36i squared. So we can simplify a little bit. I squared is negative 1, so here's my negative 1. And so 25 plus 36 is 61. And so if I divide these, then I get 15 divided by 6i, 18 divided by, not 6i, 15 divided by 61, and 18 divided by 61i, okay? So whenever you are trying to write this in standard form, the idea is that you're not going to have an I in the denominator. And so to get rid of it, we would need the conjugate, okay? Let me see if I have another one. Okay, I don't have another one, but let me just emphasize the shortcut here. So multiplying this times its conjugate gives us this long thing. But the shortcut is, since we're going to get a 0 here anyways, it's to square the first number 5. We get 25. And then we square the 6. We get the 36. Okay. And so you end up with 25 plus 36. All right, so let's try this one. We want to add these together. So negative 75, square root of negative 75 plus square root of negative 12. We'll take care of these negatives first. So I can write them as negative 1 times 75 and negative 1 times 12. Okay. So negative 1 is the same as I squared. And so notice here, I just went ahead and replaced that. And now I know that the square root of I squared is I, so I can bring that I outside. And the square root of I squared is I again. So I have 75 and 12. So we need to simplify the radicals. 75, I can write it as 25 times 3. And 12, I can write it as 4 times 3. Now my goal is, if the first one, notice here I wrote 25 times 3, then my goal is going to be to try to use this 3 and ask myself, can 12 be divided by 3? And it can, right? So it's 4 times 3. And the reason I want to ask myself that is because if I take the square root of 25, I get a 5. So I'm going to bring it out here. If I get the square root of 4, I'm going to bring the 2 outside. But now look what happens. You have a square root of 3 and a square root of 3. So the number inside, which we call the radicand, is the same. And so since it's the same, we can actually add these numbers in front of the square roots. So 5i plus 2i is 7i square root of 3. If they were different, let's say you had a 5 here instead of a 3, then your answer would just be that whole thing. Okay. But since they're the same, then we can combine them as one. And then in standard form, you would have 0 plus 7i square root of 3. All right, so let's look at this example. It says solve the quadratic formula. Again, since it says to solve the quadratic formula, notice that this is equal to 0. So some of you are going to try to factor. And just remember that if you try to factor, then that's okay. But if it doesn't factor, then you can use a different method. Okay. All right, so this is not factorable. So here's your quadratic formula that we'll use. In order to use this, we have to identify a, b, and c. So a is the number in front of x squared, which is a 1. B is the number in front of x, which is a negative 2. And c is the constant, so that's going to be 2. So we're going to plug in these numbers. So we have negative b is negative 2, plus or minus b squared, negative 2 squared, minus 4 times a times c. So a is 1, c is 2, divided by 2 times a. So if we simplify, negative negative is a positive, negative 2 squared is 4, negative 4 times 1 times 2 is negative 8, and 2 times 1 is 2. So 4 minus 8 is negative 4. And so we can still simplify. Remember, if you have a negative here, we can now deal with that, right? So negative, I can write as negative 1. And then in turn, I can write it as I squared times 4, and the I squared comes out as I. What's the square root of 4? 2. So the square root of 4 comes out as a 2. And I'm dividing this by 2, so I can write it as 2 divided by 2, and then simplify further. 2 divided by 2 is 1. 2 divided by 2 is 1, so we just get an I. So our x-intercepts are imaginary numbers, right? So where do you think the graph is? Let me draw here. Let me get my pencil. Since I know they're imaginary, then I know that my graph is never going to cross my x-axis here. It's never going to touch it or cross it. So that means that my graph is going to be somewhere up here in this top part, right? Or it might be down here, but the main thing is that it's not going to cross this x-axis because it's an imaginary solution. So my answers are x equals 1 plus I and x equals 1 minus I. And then Mr. Carizales put something in the chat, right? So sometimes they want you, you want to separate your answers. So you would write them as he did in the chat. You would write 1 plus I, comma, and then 1 minus I. Any questions on that? So now WebAssign is also trying to help students with syntax errors. So sometimes if you put an answer and it tells you like check your variables, that means that you're using the wrong variable, or maybe instead of a lower x, you use a capital X. It might ask you to like make sure your numbers are entered in descending order or something. So now it's trying to give you little hints on if you're making just like a syntax error. Okay. So we have about 10 minutes, so we can, if you have any questions, you can stay here and ask us. If not, then for sure next week, I'll let our fellow wonderful staff put up the flyer for next week here in a second. but I believe we're going to be talking about the zeros. Okay, so finding the zeros. And so in this next happy hour that we're going to have next week, this idea here is now we're going to put everything that you have done from 2.1 up to 2.4, and now we're going to put it all together and connect the pieces to make ourselves some graphs. And so you guys have a great weekend. And if you have any questions, let us know. Mr. Carizales, you have any last comments?
No, no comments. Again, thank you all for joining us. Love to have you here. We love the fact that you guys participate. I love it when you guys answer and ask us questions on the chat. So please don't stop. Keep on doing it. Thank you guys.